Hello friends, once again welcome back to Alchemy Academy platform. So in this video lesson I'll discuss about overview of CDU VDU unit. So basically in this video I'll discuss what do we do actually in this crude distillation unit. So basically what do we do in the crude distillation unit, that we take crude, that crude we take and be processed into the CDU VDU unit. Basically this is that unit, CDU and VDU unit, crude distillation unit and vacuum distillation unit. So what do we do here? Basically we do a distillation, and crude is basically a mixture of different valuable petroleum components that we want to separate, and that separation basically takes place in the CDU VDU unit. So valuable components that we separate are basically LPG that we use into the households for cooking purpose. Then we get a petrol, MS, motor spirit. Basically directly we don't get motor spirit, this is the end product. Here we will get SRN, straight and naphtha, heavy naphtha. That SRN we process into the NH2 unit. From there we'll get heavy naphtha and light naphtha. That light naphtha will become the feed of isomerization unit. There will get isomerate, and that heavy naphtha will process into the CCR unit. From there we'll get a reformate. Those will go for the blending, and that final product will get as a MS, motor spirit, and it's called as a petrol, that we get it. So basically those components will separate based on the boiling point. Then we'll separate kerosene, that then we will separate diesel. These are few components that we separate from the CDU unit. Then after that in VDU unit will process that reduced crude oil that we get from the atmospheric column, will process to the vac column after heating into the vac heater. From there we'll get different useful components like LVGO, light vacuum gas oil, SVGO, heavy vacuum gas oil, slope cut. Then bottom will get vac residue, or we call it as a short residue, that will go to the BB unit, bitumen blowing unit. From there we will get bitumen. What we will get? Here we will get bitumen. So bitumen basically it is a component that we use into the road making of roads. So this is just a overview. Just now I have told you. I'll explain the process flow diagram, the process flow description. I'll explain in the details here. So what happens, that crude basically that we get into the refinery in the refinery tank form. So what happens, that crude oil basically we buy from the other countries like Russia, Iranian, US. Crude will be there, that we buy it from through ships. It will come to the jetty. From jetty single mooring point will be there. From that single mooring point loading and unloading hose will be there. Via that it will come to marine tank pump. What we call it? We call it the MTF marine tank pump. Some companies will not have MTF marine tank pump. They directly transport from SPM to directly to refinery tank farm, actually RTF. So refinery tank farm will be consist of a different tanks will be there in the refinery tank farm. In that few tanks is of crudes. So 4 to 5 crude tanks will be there. From that crude basically now we have to send that crude to CDU VDU distillation unit. So from crude tanks a pump will be there. That pump we call it offside crude feed pump. So this pump will be near the crude tank. So this pump will take suction and discharge. The discharge of this crude feed pump will come to the suction of the crude feed pump. So this is called unit feed pump. Okay. Now from this feed pump it will go to the preheat train 1, where we will heat the crude. Now normally in refinery tank form that temperature will be around atmospheric temperature only. So after that it will get heated and it will comes around 115 degrees Celsius. After that will add wash water. Due to addition of wash water, this wash water also we will heat, and then after heating only we will mix it, and after mixing this temperature will drop to around 112 degrees Celsius. This wash water injection, after that here will come a mixing valve. What we call mixing valve. I'm just telling the process flow, that process flow details of each equipment I'll explain later in this slide only. As of now flow I'm telling that how this flow path is going from which equipment. So feed pump, then preheat train 1, then it will goes to here wash water will inject, then after that mixing valve will be there. After that it goes to desalter. From desalter, the desalter booster pump there, it will boost the pressure. Then after that it go to preheat train 2 and 3. So this is called basically 2. It can be single train or double train. If 2 and 3 will be there, so basically it will split into 2 streams. One stream like this, one stream like this, and here series of exchanges will be there. Okay, after getting heated to desired temperature, both stream will combine, and that temperature will come around to 60 degrees Celsius. After that, it will go to pre-flash drum. From that, will remove the lighters. Then after that, it will go to heater. From heater, will heat this feed from 258 degrees Celsius to 375 degrees Celsius. So basically, why do we need to heat? Because that basically proper in order to separate that useful petroleum components, the distillation will occur at a particular feed temperature. So that temperature will get the maximum flashing and maximum desirable maximum that desirable component separation. So at 375 degrees Celsius, it will go to atmosphere column. Here it will go to the feed tray. Then after that atmosphere column, different components will separate, and then from bottom, that will be called RCO, reduced crude oil. It will be around 360 degrees Celsius. Then will heat into the back column, vacuum heater. It goes to 390 degrees Celsius. Then will process into the vacuum distillation tower. From there, will separate different components like LVGO, HVGO, slope cut. Then bottom of this vac column, vac residue or sharp residue, we call it, at 385 degrees Celsius. It goes to, after cooling and all rundowns, it can go like refinery for a refinery fuel oil burning purpose, or else it goes to the BBU, bitumen blowing unit. From there will generate bitumen. So this is the process flow diagram, what I explained, the process flow path I had explained. Now I'll explain the purpose of each equipment and how do we operate it. So you can see it here. Now this, from offside crude pump, it comes to the feed pump. Discharge of this will come suction of feed pump. Prior to that, we will inject demulsifier. The role of demulsifier I'll explain while explaining the objective of desalter purpose. So after that, we will heat it. It will be around atmosphere pressure. Then we'll heat to 115 degrees Celsius. Why do we need to heat it? So reason being, when you heat the crude, what will happen is viscosity will decrease and fluidity will increase. Reason being, we want to increase the fluidity because after that we'll inject wash water. Wash water purpose, basically this crude oil, that crude oil will be there. Crude oil will contain some impurities in the form of salts. Then it can have metals. Other impurities will be there, sludge and all. So these metals and salts are undesirable if we process into the downstream units or desalter. If we don't remove salts and all, it will cause corrosion and damage the equipment. So our objective, we have to remove that salt. That's why wash water will be there. After that, it will goes to the mixing valve where thorough mixing will be done through that. So what happens? The crude will be in the form of emulsions will be there. In that, trapped salt will be there. So when we inject the water, we want that trapped salts or some dissolved salt which are in the crude oil, that has to be dissolved in the water. Once it gets dissolved in the water, will process into the desalter. So I was telling, objective of demulsifier, basically the demulsifier, basically the emulsion, bigger emulsion will be there, that will break it, so that when we inject wash water, we inject in that crude oil, so that proper mixing should be done and that water should be able to absorb or dissolve the salt which are present in the crude. So that's why demulsifier, basically 3 amount of demulsifier we inject here, 3 to 5 weight percent ppm weight percent we inject it. So after that, it comes to the desalter. So objective of desalter is to separate, basically remove the salts. How? In the desalter, we will maintain a voltage. Basically the refinery desalter that we operate here, it is a kind of electric desalter. Here we'll apply around 15 to 20 kV of voltage. What happens? Here plate will be there, positive charge, there negative charge will be there. In that crude, once we process the desalter, what will happen? That water droplet, due to this effective electric charge, one water droplet, suppose this is there, this is one. So here positive charge is there, here it will have negative charge, because water molecules are polar in nature. Due to that, here negative partial charge will develop, because this positive negative, because then again here negative is there, then bottom of this water droplets will develop positive, then here it will develop negative. Here negative is there, then it will develop positive, then here negative. Here positive is there, here negative, then it is positive. So due to this positive, this negative water droplets will try to come closer to each other, and after some time the droplets, small droplets will come together, will form a bigger droplet, then further about bigger droplet, and it coalesces, and due to gravity it will drop to further. So that's how that separation happens in the desalter. So in this, basically water separation will be happen. Water will come, goes to the further treatment to sour water stripping unit. Here that label controlling, that interface controller will be there. There will control the interface label, and the top of the product will be of crude oil. That crude oil will go to the booster pump section. From booster pump section it will pump to the preheat train 2 and 3. Now we want to heat further from 1112 degrees Celsius to 260 degrees Celsius is get heated in preheat train 2 and 3. Preheat train 2 and 3, basically it will be series of exchangers only will be there, and there we will heat the crude from the that pump around flows atmosphere and back column. That pump around will be there, and run down withdrawal will be there. That hot stream will process here for the heating purpose only. So once heated to 260 degrees Celsius, what is the reason, why do we want to heat this crude? Basically in order to separate this different useful components from crude, we want distillation. The distillation will happen at a particular temperature, feed temperature we want to achieve. That feed temperature is around 370 to 380 degrees Celsius. Now here we want 375 degrees Celsius. So 375 degrees Celsius, particular flashing will happen. We want to achieve this temperature, that's why we are trying to heat. Once it's heated to 260 degrees Celsius, will process to the pre-flash drum. Objective of pre-flash drum is to remove the lighters which are present in the crude, to directly, once you flash it, the lighters will generate, it will directly goes to the atmosphere column. Okay. So we don't want this lighter to go through the heater, because heater load will increase. So that's why we want to remove, because lighters we don't want to process through the heater. Thereby, once you remove part of this, lighters from the pre-flash drum, what will happen? Your throughput will increase. So objective of placing the PFD is, main reason is to increase the throughput of the unit. After that, once lighters separated, then after that pre-flash drum bottom pump will be there around 258 degrees Celsius. It goes to heater. Heater basically objective, it normally in the CDUs and VDUs we use mostly ballast draft heater. In that FD and FD fan will be, ID and FD fan will be there. In that, prior to this crude goes to heater, it splits into different passes, mainly 3 to 4 passes is split, and it goes to the convection and radiation section of the heater. Then after that it comes out, and all the 4 passes will combine together and join into a single stream. That single stream temperature basically we monitor. That temperature we want 375 degrees Celsius. That controlling will be given on the fuel gas firing, fuel gas firing. From that will temperature, if it is going that 370, suppose I want 375, it goes to 380 degrees Celsius, what will happen? This COT, we call it COT, this controller will give a command to the fuel gas, controlling on the fuel gas. It will give a command so that I want this reduction. It went to 380, so this temperature has to be reduced. Okay, then what will happen? That control valve will start closing. Okay, or if suppose this temperature went to 370, then it will give a command in such a way the fuel gas firing controller should open, so that it will maintain this temperature. So this is how heater controlling we will do. Regarding heater controlling video I had already made, the link of that video I'll give it into my description box. From there you can watch. After that it comes to the atmosphere column. From that it will be processed. After that we maintain the column profile. How do we maintain? Basically here one pump around, here in the different withdrawals will be there. The top product here from atmosphere column, what will happen? It goes to the overhead receiver. From here it will goes to the condenser and all. From condenser this is a salt water, so from condenser it will goes to overhead receiver. From overhead receiver pump will be there. So part of that light pressure distillate here accumulated, part of that will goes to the column as a reflect, and part of that it will goes to the stabilizer, where it will go to stabilizer. From stabilizer we will remove the this low pressure distillate will go to the stabilizer. From there we'll remove the LPG and SRN, straight run naphtha. Basically from top top of that stabilizer is the LPG that we get it, and the bottom is SRN, straight run naphtha. Basically this SRN we get from atmosphere column, it goes to MS block, basically NHT unit. From NHT unit we process. After processing we'll get light naphtha and heavy naphtha. Light naphtha becomes the feed of isomerization unit, and heavy naphtha becomes the feed of CCR unit. From there we'll get reformate, isomerate. Those will go for the blending and as a final product is petrol after lab certification. So this is the overview of the top section. Then from there withdrawal will be there. Here one withdrawal will be here. Top pump round will be there, where one section of withdrawal will be taken. Here withdrawal will be taken care. No product withdrawal will be there in order to maintain the temperature profile. Part of that after cooling this stream will send as a top pump round for maintaining the column profile. Then after that heavy naphtha withdrawal will be there, kerosene withdrawal will be there, then diesel withdrawal will be there. This withdrawal will be there on the chimney tray. Basically this in column we maintain the temperature gradient, and we know based on the design value that at this particular temperature heavy naphtha withdrawal will be maximum. It will be on spec. So normally 165 we consider as the temperature at which if we withdraw it will get maximum naphtha. And after that simply maximum heavy naphtha. Then we'll get a kerosene at 215 degrees Celsius, then diesel at 315 degrees Celsius. Similarly, what product will withdraw here, it goes to basically stripper, kerosene stripper, then diesel stripper. From there will strip off, lighters will take out, then those components further goes to the kerosene or diesel goes to the cooler. From their cooler will go to the rundowns. It will go to the for treating units basically. And from there only PA air pump round will be there from product. Before that, it's suppose this is going to product streams. From here one pump round will be there. Once it gets cooled, again we send it back to the column for maintaining the column profile. Similarly for Kero also, Kero pump round will be there. Then after that bottom product we call reduced crude oil at 360 degrees Celsius. We get it from here. We'll pump to the back heater. From back heater it heated to 390 degrees Celsius. Then we process to the back column. So basically back column, why do we call it the back column? Because we operate here on the vacuum. How do we get this vacuum? Basically here series of ejectors will be there. Here ejectors will be there. By steam ejector we maintain a vacuum. Then after that it will go to the condenser. From condenser it will go to the hot well. This overhead receiver I have sold basically is a hot well receiver. What is hot well receiver? The liquid product of in that phase separation, that boot will be there, and that water basically will go to sour water as a SWS unit, sour water stripping unit for further treatment. And then the hot well, the liquid hydrocarbon will get, it goes to the slope cut for further processing to the crude. And the top of the product will go to the absorber column. Basically this absorber column is basically amine absorber column. Then after that treating that off gas with the amine, it becomes a sweet free of H2S and all. Then it goes to the heater for the burning purpose. We use it in the burning purpose. Similarly top product here column profile we maintain at 168 degrees Celsius will withdraw LVGO, light vacuum gas oil. Then 280 degrees Celsius will withdraw HVGO, heavy vacuum gas oil. Then 360 around will withdraw slope cut. So LVGO and HVGO basically is not end product. We cannot directly sell it. So what we do, LVGO and HVGO we process into the FCC or hydrocracker unit. Basically it goes to FCC unit. From FCC fluidized catalytic cracking unit. Basically from here we'll get different useful product from this. So different useful, here also we'll get LPG, we'll get here CRN, basically we call it cracked run naphtha. This CRN RON will be higher, around 393 to 94 RON will be there. That once it is treated in the FCC industry, it becomes a final product only. Then SRL will get here, diesel will get, then after that bottom product will get a slurry or a CLO, clarified oil we call it. Once it is cooled, that goes to the this fuel oil for burning purpose, heater and all, or else we sell it to the ships. We sell that oil, the fuel oil, to the ship and all. For normally ship uses fuel oil and all. So then bottom of the back column, it called as short residue or back residue, is basically 380 5 degrees Celsius. It is further through the back bottom pump, it goes to the rundown. Rundown basically after cooling and all we send to the rundown for this fuel oil header. In that, be part of that oil we can use into the heater for the fuel as a fuel oil firing purpose, or else this vac residue will process to the bitumen blowing unit. What will happen is a higher temperature, so we process it to the steam gen and all for recovery of it. There will generate steam. For that, once it's come down, it goes to BBU reactor. Here in the reactor, agitator will be there and air will be given. Once it will agitate and gets polymerized, after that the bitumen will go to the steam gen. For further temperature we want to reduce, it goes to the steam generation and all. Once further cool, it becomes a bitumen, final product bitumen, and it goes for the selling purpose. So this is what I wanted to explain in this crude distillation unit is process flow diagram, and I tried to cover maximum. So this is all regarding the process flow description of crude distillation unit. If you guys have any doubt in this video, you can comment in the comment box. I'll try to clarify it. So guys, thank you so much. One question I'll mention here, I did not tell here. Basically over flash we maintain one withdrawal will take. Here RO will be there, and after this RO through it will send it back to the column. The purpose of this overflashing is basically we don't take any withdrawal on. Purpose is to be monitor whether that label, based on this flow, will monitor whether that label of the top trays are emptying or not. So basically for maintaining the column profile, this is one of the parameter for seeing. Other parameters we'll see for column profile is bottom pressure, top pressure, DP across the column. One of the major parameter to column, whether columns is going under flooding or not, is the delta P. Then back also is basically delta P. Basically, and other things I did not tell you, basically LVGO. In the back column, basically piping will be there. Basically here will not be having, here suppose trays are there, here piping will be there. In the piping, normally two types of reflux will give: external reflux, top reflux, then internal reflux also we will given. So here LVGO, top reflux also we will be giving, internal bottom reflux will be there because it's not going on the tray. So after that, distributor and all will be there. So it goes into the piping proper mass transfer. Similarly, HBGO also, IR and AR will be the external reflux, the internal reflux will be there. So this I did not tell in this while explaining. So guys, I hope I have covered all. So guys, that's all. So thank you so much.